Hey class, good morning, good afternoon, good evening, whatever this is. We are going to be talking today in supply chain about production and manufacturing. So let me share my screen here so that you guys can all see what I'm looking at, and we will get started. I hope you all are doing well, enjoying your semester. We're nearing the end now, so yay, even though you know that I'm taping this in advance. I hope you all are well. So again, we're going to talk today about production and manufacturing. So let's think back to way in the beginning, the first day of class, and I talked about the three big things that supply chains do. I talked about how we buy things, we do procurement, we have to buy all those raw materials necessary to actually make the products and services that we are doing, and then we actually have to make them. This is what we're going to talk about today: the production, the manufacturing, the operations. We're going to make exactly what it is that we do. And then we've already talked about moving and storing things. We've talked about warehousing, we've talked about transportation. So again, today we're going to talk about this middle piece, making things. So let's go back to that original analogy that I used about a sandwich. Again, something very simple we've all done in our entire lives. Let's talk about the production and manufacturing of making a sandwich. Again, this is where we're actually going to make our product. We've got to put our sandwich together. Right now, all we have are a bunch of loose ingredients that mean nothing unless we actually put them all together in the right order, in the right format. This is production and manufacturing. So some of the big things we've got to ask ourselves before we start the process: do we have the correct tools? Do we have the correct equipment to make the sandwich? Do we have the right places to store all the ingredients to ensure that they are fresh and we can keep them until we are actually going to make the sandwich? The timing of when we make the sandwich. Do I make the sandwich the night before, or do I make it in the morning? Do I make it 2 weeks in advance? Do I make it 6 months in advance and freeze it? Whatever the case may be, we've got to think about when we're going to do it. So let's break down the tasks that we need to make the sandwich. Again, we're going to make like a really good, like quality sandwich, not like a crappy peanut butter and jelly. So we're going to slice the veggies. We're going to toast the bread. We've got to cook the bacon. We've got to compile all the ingredients correctly and in the right order. And then, of course, we've got to store all the leftover materials. And we've got to clean up the mess that is going to occur. So these are all the things that we've got to think about. And apologies, looks like the power has gone out, so bear with me. Now, without production manufacturing, we don't have a sandwich, we don't have a product, we don't have a service. We would just have some loose assortment of random raw ingredients, not a good quality sandwich. So doing these things that we just talked about, when to make it, how to make it, storing things properly, compiling them properly, doing these things the right way and doing things quickly and being able to do it over and over and over again on a repeatable basis is what people in operations do every day. So again, this is where our product, our service is going to come to life during this stage. So this is a very important stage of the entire process. So let's talk about manufacturing. Here, let me see if I can move myself so you guys will be able to see. There we go. So now you can see the actual definition. So let's go for the definition of manufacturing. This is going to be very important. I guarantee you will see this on the test. So manufacturing, what this is the large-scale production of goods that converts all our raw materials, all our loose parts, all these components into a final finished goods. And this is using machines, which is going to be important, machines, tools, could be human labor, chemicals, etc. And manufacturing is a huge, huge integral part of the economy. In 2021, manufacturing contributed $2.3 trillion to the US GDP, which is 12% of the US GDP. So just in and again, we're not even one of the biggest manufacturing country. It is over 10%, 12% of the US total GDP in 2021. So it's very important to our economy. Again, manufacturing, the large-scale production of goods that converts all these raw materials, parts, components into these final finished goods using machines, using tools, using human labor, could be even using chemicals, etc. So let's talk about manufacturing. So the word manufacture is actually derived from, it has a Latin origin, as many words do. So the two words manu and factus. Manu essentially means hand. And what it translates to in Latin is made by hand. Most objects that we use every day are the result of manufacturing. The computer that I am recording this on is made for manufacturing. The device that you are watching this on is made for manufacturing. The chair that I have sitting behind me is made for manufacturing. The mouse I have, that is, there we go, so it's not too fuzzy, is made for manufacturing. The garments that we are all wearing are made for manufacturing. Again, manufacturing is that step within supply chains where products are going to come to life. Again, this used to be just like loose threads, loose material. Now it is actually a garment that can be worn and is a good final project, or a good final product. And what manufacturing involves, that is the processing and refinement of all these raw materials into finished products. It's making it come to life. So let's give some examples of what I mean by these raw materials. So we've got just raw iron ore, and you can see a picture, just literally just the raw. It has no value to us just as the rock on its own. But once it goes through that manufacturing process, it becomes a metal good that is of use to us. I think the metal good I have here is some sort of patio furniture where you can sit out, have a beer, have a burger with your friends on a nice summer day. Again, the raw iron ore has no value to us, but when it goes through the manufacturing process, we've got the final finished product that has value. And then we've got wood. There's a ton of stuff that's made out of wood, lots of furniture. Just a log in and of itself doesn't have a lot of value. Yeah, you could use it for firewood, but it doesn't have a ton of value for most everyday people. However, once it goes through that manufacturing process and it's a quality piece of furniture, that has value. And then all the foodstuffs that we eat. Again, all those raw ingredients, the flour, the oil, the milk, the baking soda. Again, you can't eat those just raw on their own. You've got to put them all together. You've got to cook them correctly to have that delicious Twinkie that you see there. So everything needs to go through some sort of production manufacturing process that's going to add value and create that final product that is actually of value to us as the final consumer. Again, manufacturing converts raw materials into something more useful that adds value. You are not going to get a ton of value on a bag of loose flour and eggs and baking soda, but you are going to get value from that final finished cake. And what this added value, this increases the price of finished products, and it makes manufacturing an incredibly profitable part of the business chain. So it adds a lot of value to it. Manufacturing processes are used to make everything that we buy, ranging from even like apartment buildings all the way to the pen that perhaps you're writing notes with. So manufacturing is all around us, and it's an integral part of our economy. So you guys know I love doing my countdowns. So let's talk about the top 5 manufacturing countries in the world. And this is based on 2019 data. I could not find anything that was more recent, I'm assuming because of COVID. But we're going to use this data to begin with. And so this is from the UN statistics data. So which countries, just taking a guess, do you think are the top 5 manufacturing countries in the world? So think about that for a little bit and we'll go through them. So we're going to start off with number 5. Oh, excuse me, we're going to start off with number 1. So number 1, I think, does not come as a surprise to anyone, is going to be China. They have almost a third of the global manufacturing output. They have 28.7 of the world's global manufacturing output. So they are doing a ton of manufacturing here. The United States, used to be the world's top manufacturing hub, but China overtook that spot in 2010. So it's been almost 15 years since we've had that top spot. And China, of course, they have a lot of people there. They're the most populous country with approximately 1.4 billion inhabitants. And they have a very entrepreneurial an entrepreneurial economy. It is one of the best places to do business with due to its low costs. So number one on our list is China. And I don't think this comes as a surprise to many people. I think a lot of people expected this to be the case. A lot of manufacturing in China. I think if you look on the bottom of a lot of the products that are manufactured, it says made in China. Not surprising whatsoever. So let's do number two. Number two is actually us, the United States. We have 16.8% of the global manufacturing output. And manufacturing, of all the things that we export, manufacturing comprises about half of all those exported goods. And our peak, again, of manufacturing was 1979. So many, many years ago, before I was born, before you were born, that was the pinnacle of manufacturing employment in terms of the number of people who were employed, the number of Americans employed in the manufacturing sector. So at that point, 19.4 million Americans were working in that sector. That's probably why a lot of your grandparents used to work in factories, because that's what a lot of people did. However, we've got automation, we've got robotics, we've got computer technology. We don't need as many people. So output has actually increased since then, even though the number of people employed in the manufacturing sector has decreased. So yes, the United States is number two in terms of the countries that manufacture the most. Okay, let's go to number three. Oh, and here's some things about the types of things that we manufacture based on the millions of dollars that they cost. So we've got chemical products, we've got computer and electronic products, believe it or not, food, beverage, and tobacco products, motor vehicle products, metal products, machinery, aerospace, petroleum and coal products. And then we've got plastics and rubber products. So a wide variety of different things that we in the United States manufacture. So this is just a little breakdown. Okay, number three is Japan. They have 7.5% of the global manufacturing output, which is really surprising because Japan is a very small country in terms of land mass, in terms of people, especially compared to China and the United States. Number four, we've got Germany. They've got 5.3% of the global manufacturing output. And the German economy, it promotes the free market, so it makes sense. And especially in the both the business and the consumer goods sectors. So Germany actually is number four on our list. And let's bring in the rear with number five. Number five is going to be India. They've got 3.1% of the global manufacturing output. Usually when we think of India, we think of outsourced IT support or customer service centers when you call up to complain and you get someone that very obviously is working in a call center and has a very strong Indian accent. However, they are also known for their manufacturing. They had over 412 billion in 2019 from their manufacturing output. So that is the top five. We've got China, we've got US, we've got Japan, we've got Germany, and we've got India. So I know a lot of people assumed like smaller Asian countries would be on this, but you see the top five. So here's just a list of the top five so you can see it visually. And then after that, we've got South Korea, which has 3% of the global manufacturing output, Italy with 2.1%, France 1.9%, UK 1.8%, and Indonesia. So we actually see a lot of European countries on this list with Germany, Italy, France, and the UK on this. So a lot of manufacturing taking place in these countries. So let's talk about the history of modern manufacturing. So let's go back to the Industrial Revolution. So this was a time when we moved, again, society moved from creating goods by hand and we started using machines. And this really occurred in Europe, primarily Great Britain, and in continental Europe, and also in the US. And there's varying timelines that different experts will give you, but from about 1760 to 1840. And that marked the transition from human labor, everything done by hand, into machinery and chemical manufacturing processes. So this turned artisans, people making things by hand, into wage laborers. So before the Industrial Revolution, everything was handmade products dominated all of our markets. And each individual product was made individually by hand by someone. So you think, oh, how quaint, how nice, this must have been like fantastic workmanship. But think about that. That is a very time-consuming process. And also it's going to be riddled with inconsistencies between the different final products. So you're not going to have a lot of consistency between different products because each one of them is made by hand and there's going to be different things that happen with them. So this is pre-industrial revolution. And then we had the invention and the improvement of steam engines and other types of technology where companies could easily adopt machines in the manufacturing process. So we could increase the volume of finished goods. It reduced the number of workers needed to produce them. So we were really getting economies of scale. We could produce a lot for not a ton of money and not using a ton of labor. So this was a huge change in how things had been done before, a very labor-intensive, time-consuming process to make things to much more streamlined. And we have economies of scale where we're making more with less. So the next shift in manufacturing was the introduction of the assembly line in the early 1900s. So the very first assembly line was patented by not Henry Ford. Most people think Henry Ford, and we're going to talk about him, but it was actually patented by a guy named Ransom E. Olds in 1901. So he was a car manufacturer, and he is actually the namesake for the Oldsmobile. However, it wasn't the assembly line that we're used to now. His assembly line was stationary, so it stood still, and the workers would move around the assembly. But this was the first new approach in putting automobiles together. And it enabled Ransom E. Olds, to increase production by 500%. So in 1901, his company was able to manufacture 425 cars. And by 1902, using this stationary assembly line process, he was able to increase that to 2,500. So huge increase in production. And again, we take this for granted that cars, that you would use assembly lines, but this was new and groundbreaking. So the next one, we're going to talk about Henry Ford. He is credited as being the father of the modern assembly line, as well as he is the father of mass manufacturing in vehicles, in automobiles. So he took old system of this assembly line and he improved upon it. So he used moving platforms. He used a conveyor system. And again, it was only just 10 years after Olds had patented his. So on December 1st, 1913, Henry Ford, he installed the first moving assembly line for mass production of the entire automobile. And this reduced the time to build one of his Model Ts from 12 hours to only an hour and a half. So huge improvement. And what Ford did is he broke down the Model T's assembly into 84 very discrete steps. And he trained all of his workers who were all unskilled. These weren't mechanics. These weren't experts in anything. They were unskilled workers. And all he did was teach them just how to do one of these different 84 steps. And he also hired a motion study expert, Frederick Taylor, to ensure jobs were done more efficiently. So how it worked in the beginning, back in 1913, is that the Model T vehicles were towed by rope and they would move them from station to station. So this way, workers could simply just assemble the different pieces as the partially made vehicles arrived to their different stations. Again, groundbreaking. It made everything so much quicker. And again, you didn't have to have someone who knew how to make a car all the way from bare bones all the way to the final product. All you had to do was train them on one single step, which had never been done before. And prior to this shift in how he manufactured his vehicles, cars were an extremely expensive luxury item. Only the elite of the elite, the 1%, the creme de la creme, could afford a vehicle. So the Model T was fairly expensive when they first released it in 1909, before he introduced the assembly line process. And initially, the cheapest price was about $825, which is about $18,000 in today's currency. So not crazy. But as production efficiency increased. They started using these assembly lines. They were able to make it quicker, cheaper, and he was able to pass those savings on to the final consumer. So Ford was able to drop prices drastically, so vehicles were more affordable. And by 1924, just 15 years after that first car came out, the price had gone down to only $260. So down by almost 2/3. So crazy how affordable these became for just the average person. And let's go to the next one. So the next big breakthrough in manufacturing is Toyota. So in 1948, Toyota Motor Company developed what they called is lean production. And we're going to talk a lot more about lean later in this chapter. You probably have heard the term just-in-time, JIT manufacturing. That is closely synonymous with lean production, and also the Toyota Production System, TPS. So what this was developed by Toyota in order to improve the flow of production by finding, identifying, and eliminating any kind of waste. So waste, the Japanese word for waste is called muda. And under lean production, there are 7 different kinds of waste. There's transport waste, there's movement waste, there's waiting waste, there's overprocessing waste, there's defects waste, there's inventory waste, and there's overproduction waste. We're going to talk a lot more about that. But it was a drastic change from previous systems, and it required a lot more persistence and detailed observation. So this was the next big breakthrough in 1948. And again, the process was mostly confined to Japan until the 1970s, when UK companies decided to start adopting their own version of lean manufacturing. And by 1990s, the concept of lean manufacturing had begun to spread outside of the automotive industry. For most of that, from 1948 to about the 1990s, it was mostly confined to the automotive industry. By the 1990s, it spread to all sorts of things. Now you see lean concepts used in electronics, in aerospace, in healthcare, in construction, food, even services. So lean is used everywhere now. And now we've got the rise of robotics, the rise of automation, and the rise of what we call smart manufacturing. So the first robots started to appear on our American assembly lines in about the 1980s. And now, today, we have all sorts of automated manufacturing that uses advanced robotics. It uses big data. It uses incredibly sophisticated computer software. It can complete tasks much faster and much more precisely than humans ever could. And it can do it 24 hours a day. They don't need to take bathroom breaks. They don't need to rest. So this is where we're at now. We're seeing the rise of robotics, automation, smart manufacturing. Okay, so we've been talking about manufacturing. Now let's talk about production. And again, the two are very closely related, and we're going to talk about what the differences are. So production, this is the process of combining various inputs in order to create output which is fit for consumption. So we're going to have a final product. Ideally, this output is going to be some kind of good or service which has value and contributes to the utility of individuals. So again, very closely related. It sounds very similar to the definition of manufacturing, but we're going to talk about what is the difference between production and manufacturing. So what is the difference? They sound very similar, right? Manufacturing, production, we're talking about them all now. Let's talk about what the difference is. And this is going to be very important. So every type of manufacturing falls under production umbrella. So every type of manufacturing is production. The biggest difference is that in manufacturing, we need machinery. There is going to be machinery used. In production, machinery may or may not be used. So that is the big difference with manufacturing. Manufacturing uses machines, production may or may not use machines. And also in manufacturing, the result is a good, only a good. In production, the final result can be a good or a service. So these are the 3 big differences with production and manufacturing. So very important to remember. And I guarantee there will be a question on the final with this. So know the difference between production and manufacturing. So manufacturing requires machinery, production doesn't necessarily need it. And in manufacturing, the final product is goods, where in production, the final product could be goods or services. So let's talk about some different principles that we can apply in manufacturing and production. So some products are manufactured according to forecasts, where they're not going to have specific sales orders already input. We're going to use our sales forecasting that we talked about many, many lessons ago. And again, other product manufacturing only starts after we actually receive a sales order. And different strategies are going to result in different lead times. So what a lead time is, this is the time that we as a business need to respond to a customer order. From the time you input that order, you want something, to the time we actually deliver it to you. That is the lead time. So we can structure these according to different principles. So we could either do make to stock, we could do make to order, we could do assemble to order, or we could do engineer to order. And let's talk about all four of those. So let's talk about make to stock first. And you're probably going to see the acronym MTS. So this is the very traditional production methodology where we are going to produce products in advance and we are going to stock them as inventory. So they're going to sit on a shelf somewhere until a customer actually buys them. Oh, and the lights came on. Yay. And again, this is based on demand forecasts. We're going to do sales forecasts, and then we're going to manufacture according to that. So usually our products are created in very large batches. And again, they're held in stock, held in the back room, held on a shelf, held in a warehouse until they're actually needed. Usually these types of products that are made with a make to stock type of methodology usually have a very low level of customer specificity. So you're not going to be able to put in special orders for them or put in unique things. They have a very high degree of standardization. And they also have the highest levels of inventory investment of all the different production strategies. So we're going to be spending a lot, and a lot is going to be tied up in inventory. And because of this, make to stock is prone to waste, it's prone to obsolescence, because we have so much inventory sitting on shelves awaiting for our final customers to actually purchase them. And this really started with the idea of mass production in the early 20th century. So this came from the practice of we are going to produce high volume of exactly identical goods at a low cost, and we're going to create them in large numbers. And again, we're creating them in anticipation of future demand based on the forecast that we create, and we're going to keep them in inventory for a later sale. It's really the appropriate type of production strategy for standardized goods, which can be the foods we eat to electronic appliances. Really fast moving consumer goods are an example of a typical make to stock item. So toothpaste, soap, cookies, makeup. These are all non-durable consumer goods that sell quickly, and they sell at a relatively low price. So companies like Nestle, companies like PepsiCo, companies like Procter & Gamble, they typically utilize a make to stock strategy. And again, so these are the types of things that we would use a make to stock strategy for. Okay, now we've got make to order. So the manufacturing or the production process for these types of items begins only after we actually receive a confirmed customer order. And these typically allow you to purchase products that are customized to your exact specifications. So you can personalize it, you can special order it, you can customize it exactly what you want to make it in a make to order process. These are products that usually have a very high demand, but usually have a lot of different variations. If we made all identical ones, it would not be ideal. The advantage of the make to order process are we're going to have a lot of enhanced customization level. And also we're not going to have a lot of excess inventory. We're only going to produce the product once a customer actually puts the order in. So we've got better productivity. We've got a lot of variety in the things that we're doing. They're not going to be all identical. The major drawback of this strategy is there's going to be a substantial time lag between the placing of the order and its delivery, because we've actually got to create it now. We don't actually start the process until the customer puts the order in. So therefore, it's really only ideal for commodities that have a very short manufacturing cycle, that it's not going to be years, months that you're waiting for your product. Hopefully it's only days, maybe weeks. So the wedding industry, I know hopefully none of you are married right now, because weddings are very expensive and that's a big commitment to make. But the wedding industry is an example of an industry that thrives on make to order. So each wedding, each component of the wedding is custom tailored to the whims of the bride and the groom, probably the bride. So wedding dresses, flower bouquets, wedding cakes, all these crazy things, favors, are all going to be make to order to the exact specifications of whatever you want. So the production is not going to start until that order is put in, and it can be made to exactly how you want it. So let's talk about assemble to order. So assemble to order, this is kind of a hybrid. It's kind of a combination of make to stock and the make to order strategy. So what this entails is that the manufacturer strategy is where the manufacturer is going to stock up on all these parts, all the inventories, all the nuts and bolts that you would need to compile the final product. They would have those on hand in inventory. And then they would assemble the final product when a customer actually places an order. So products can be customizable to a certain extent. And what this does is this relies on the company's ability to assemble and deliver the goods very quickly. And it usually takes a longer time to deliver the final goods to the customer, very much like a make to order strategy. So a company that employs an assemble to order strategy is Dell. So Dell Technology, they follow an assemble to order business model for personal computers and for laptops. So I actually have a Dell and I'm very happy with it and their assemble to order strategy. So Dell, what they do is they have all the essential parts of a computer. They have the motherboards, they have the graphic cards, they have the processors, they have the keyboards, the monitors in stock, already ready to go, already manufactured. And until a customer actually puts in an order, the components are going to sit on the shelves separately. They're not going to put them together in a computer. They're going to sit on the shelves. And Dell then allows the customer to choose from a range of options for each part of the PC. So you can choose from all sorts of different levels. And when the customer finally puts in their order, when that order gets in for the PC, the company has everything on hand and they have the specs that you have chosen, that you've customized, and they're going to put it all together and they're going to assemble it and ship it out for delivery. So this is an assemble to order strategy where you've got all the components that you need to create it on hand sitting in inventory. And our final production manufacturing process is engineer to order. So engineer to order is commonly used in the creation of like one-of-a-kind products and usually very sophisticated, very complex type products as well. They usually have very unique specifications and again, are usually very complex. And it involves the creation and the engineering of a product to a customer's unique and usually very precise specifications. And again, the process does not start until after the customer order is put in. So this is widely used in the aerospace sector, military, architecture, when you're creating buildings, when you're building a house. This is going to be engineered to order. So examples of engineer to order products include commercial heating, ventilation, and air conditioning, HVAC equipment. So it's got to be specified for the exact building, the exact specifications, electrical switchgear, power plant boilers, industrial cranes, aerospace manufacturing, so building airplanes, the defense and security industry, so making tanks, making war fighter type of weapons, and in the energy industry. So again, usually very expensive, very complex, sophisticated types of systems. So usually not something simple like a candy bar or a computer. These are usually buildings, these are airplanes, these are weapon systems, these are industrial cranes. So this usually employs an engineer to order system. Now let's talk about push versus pull production. So in push production, so we're pushing, businesses are going to produce products based on demand planning. Companies are going to produce a certain amount of product to meet what we have anticipated as being the forecasted demands. And then we are going to then push our product onto the market from this established inventory, even if there is no customer order. So the company is pushing their product onto the customer. The customer did not order it yet, but we are pushing it onto them. So a make to stock is a push production strategy. And then on the other side of it, we've got the pull production. So this is based on actual customer orders. So production is pulled via that customer order. The customer is pulling the product out of us. In a pure pull type of system, no product is made until a completed order is made for it. There's absolutely no predicting, no forecasting involved. We are depending solely on customer orders. So make to order and engineer to order are pull production strategies. So again, push production, push production, we as the business are pushing our product onto the customer. And in pull production, the customer is pulling the product out of us as the company. So these are the big two differences between push and pull. And push, make to stock is a push production strategy, and make to order and engineer to order are pull production strategies, where the customer is pulling the product out of us as the company. So a really key concept in production processes is that customer order decoupling point. So what a customer order decoupling point is that is where inventory is positioned within our supply chain. So we've talked a lot about inventory. In inventory, what that does is that acts as a barrier to separate the customer from the manufacturing process. And the closer that the customer order decoupling point is to the customer, the quicker we can serve them. However, there is a trade-off. The quicker our response to customer demand, the larger our inventory holding costs are. If we have that inventory sitting right next to the customer, we're spending a lot in inventory holding costs. We're putting a lot of money into that inventory that's kind of just tied up. So this is just a graphic that shows you how there's that trade-off. We've got customer lead time at the top, and then we've got our inventory investment at the bottom. And you can see our different production strategies. We've got make to stock, assemble to order, make to order, engineer to order. And you can see, can I make my mouse? I cannot make my mouse move. But where that triangle is in each of the different production strategies is where it sits relative to the customer. The customer would be at the end. And the closer it is to them, the quicker we can serve them, but the higher our inventory investment is going to be. So this just shows you where that where that decoupling point is for all of our different production strategies. So this is our customer order decoupling points. Okay, so the next thing we're going to talk about is how manufacturing processes are organized. So how a manufacturing facility, the building facility that this is actually located in, can vary greatly in terms of how it's arranged. Ideally, we're going to have our equipment, we're going to have our machinery, and our people are all going to be arranged in a way to have the production process as efficient as possible. And it's usually determined by the workflow pattern, the volume of products that we're doing, or the level of product standardization, how similar all of these different products are going to be. So there are usually 5 major layouts, which we're going to talk about. So we've got the project layout, we've got the work center layout, we've got the manufacturing cell layout, and we've got the assembly line layout, and then the continuous process layout. So let's go through each of these. So our product layout. So in a project layout, the product is going to remain in a fixed location just because this product is so big, it is so heavy that it's got to stay still and we're going to move around it. So manufacturing equipment is then moved to the product rather than the other way around, like an assembly line. Like we're going to move the product and it's going to go to the different workstations. It is going to remain fixed just because it is so big, so heavy. It's going to remain fixed in one set location. The project layout is very common for construction sites. So for houses, for buildings, for bridges, the product itself is going to remain fixed in a project layout. Movie shooting lots are another example of this type of format. The product is going to be fixed and everything, the people, the equipment is going to be moved around it. So usually areas on this site are going to be designated for various purposes. So you've got a staging area over here. Maybe you've got a sub-assembly area over here. Maybe you've got access for heavy equipment over here. Maybe you've got like your management area over here. But remember, in a project layout, the product remains in a fixed location. Okay, our next one is going to be a work center. And this is where similar equipment or similar functions are all grouped together. So for example, if we had all of our drilling machines in one area, all of our stamping machines in another area. So a part that is being worked on will travel according to whatever sequence of operations we have from one area to another where the proper machines are located for each operation. A lot of times you'll see a work center, sometimes referred to as a department, and usually that is focused on one specific type of operation. We talked about the drilling happens over here, stamping happens over here, or we've got drilling holes takes place here, grinding operations, painting over there. And an example of a work center type of organization is a hospital. So this type of layout is very common in hospitals where there are dedicated to particular types of medical care. So you've got the maternity ward over here, you've got an intensive care unit over here, you've got pediatrics over here. Each area or department is dedicated to one particular type of operation. So that is what a work center is. And then we've got our manufacturing cell. I would call this like a mini assembly line if I were to compare it to anything. This is a dedicated area where similar products are all produced. So we've got very similar products that are going to be the end result of this entire process. And it's going to group dissimilar equipment together. And usually the product has similar shapes or processing requirements. So similar products produced, dissimilar equipment all together. A manufacturing cell is very similar to a work center in that these are designed to perform a specific set of purposes. Again, it's also very similar to an assembly line in that the cells are dedicated to a limited range of products. These are widely used in metal fabrication, in computer chip manufacturing, and for assembly work. So that is our manufacturing cell. So we've got similar products produced, dissimilar equipment used. And then we've got our assembly line. This is what we typically think of when we think of manufacturing and production. So the equipment or the work process are arranged in progressive steps by which the product is made. And these steps are defined so that a very specific production rate can be achieved. So the path for each part is essentially a straight line. So discrete products are made by moving from workstation to workstation at a very controlled rate. So it's very important about that rate. So a car wash is an everyday example of a use of an assembly line, where it's got a very set rate and you're going through all the different processes. Industrial examples that use assembly line are toys, or appliances, or automobiles. These are typically used to make very similar items that they don't have a lot of specification to them in high volumes. Virtually any product that has multiple parts produced in high volumes uses assembly lines to some kind of degree. And assembly lines are done in areas referred to as stations, and typically stations are linked by some sort of material handling device. So we've got a conveyor belt, we've got an overhead crane, and usually there's some sort of pacing so that the amount of time allowed at each station is managed. And it's, again, a very important aspect of assembly lines is timing. So timing the movement of products on an assembly line is imperative to ensure efficient operations. Okay, let's take. Okay.